I don't know. Ella. Example 4. Find the slope of the tangent line, which means the derivative of to the curve at these two places. So I'm going to have two answers because I'm plugging 2 points in. All right. We don't always, on your homework, you will not have the graph. But since I have the graph, let's do some guesstimation. So I want to know what the slope is here, and I want to know what the slope is here. What abouts do you think that slope is? Like here is where 1 is. Here is where 1 is. You think it's 1/2? Like up 1 over 2, up 1 over 2. You think it's 1/2?
I think 2.
This used to be mirrored, right?
I think
Yes.
2.
You think 2?
Yeah, the slope's like, yeah, I think 2. It's
I think it's 1/2.
Oh wait, yeah, you're right. Up 1
Like
over
he'll
2.
be
I
up
was
1 over
thinking
2.
Up 2 over 1 for me.
Up 1 over 2. I think he's 1/2, right? This line has a slope of 1/2, I think. What about this one? I'm going to say negative 1/2. We're just guesstimating, right? We will not have the graph to guesstimate, but we're going to do that, all right? Now, so what do we do first?
Plug it in.
water fountain over there.
What?
Derivative.
We need to find the derivative of this thing. Okay, now this one's nice because we don't need the product rule like we did yesterday. All right, what's the slope of y squared? Shh.
dy over dx.
2y.
2y,
dy dx, right? Anytime you take the derivative of y, it's like the chain rule. The derivative of y is dy dx, right? Because our preferred variable is x, okay? Minus the derivative of x is 1. The derivative of 1 is 0, and this 0 goes away, right? So we don't really need those zeros.
It wasn't me.
So we have this. Okay, now what do I do?
Move the 1 over.
Move the 1 over. So 2y dy dx equals 1. And then I'm going to?
Divide by 2y.
I'm going to divide by 2y. I'm going to get the whole thing to the other side. Divide by 2y. So my derivative, dy dx, is equal to 1 over 2y. Now what?
Plug it in.
Now I plug in my point. Okay? dy dx is the derivative. Normally, when they say plug the point in, we only end up plugging the x coordinate in because my derivative only has x's in them. This is a rare scenario. We only have y in our variable, right? Or in our derivative. So I'm only going to plug negative 1 in right here. Negative 1. So 1 over 2 times negative 1, which is negative 2. So negative 1/2 is at 2, negative 1. At 2, negative 1, he has a slope of negative 1/2. That's what we guesstimated. That is correct. If I plug in positive 1 at 2, 1, that is 1 over 2 times 1, which is 1/2. That's positive 1/2. That's the slope right here, which is what we guesstimated. Yeah? Whoa. Mind blown.
Unbelievable.
Boom.
That was actually mad easy. That was easier than
That was
yesterday.
way easier than yesterday's, yes. Because the derivative was easier. What?
I'm not touching you.
Oh, what if they don't give you the y? What if they just said at x equals 2?
You have to plug that in.
Then I would plug that into the original to get 2 comma negative 1. Does that make sense? And if they said like whatever, right, we would plug that in.
So then you'd have to do y equals
Yeah. Yeah, you'd have to solve for y.
mm-hmm.
Yep.
She
Okay.
told me I could smile after she
Next.
took the picture.
Same thing going on here. We only have 1 point, and this is this point. They want us to find the slope of this line. What do you think the slope of that line is?
Let's do negative 1.
Negative.
1.
I think it looks like a perfect 45-degree angle. I'm going to say negative 1. Like down 1 over 1, down 1 over 1. I think the slope is negative 1, but we'll find out. This is going to be a little bit uglier than the last one, all right?
That's not that bad.
So use implicit differentiation, that's implicit derivative, right? To find the derivative, to find dy dx of this guy, okay? So in part A, we're not plugging him in. We're only finding the derivative, okay? All right, so let's do this guy first. Derivative is 3x squared plus 3y squared dy dx, right? Or y prime if you want to call him that, right? Dy dx equals, this guy we have to do the product rule. So f and g, okay? F prime g plus g prime f. Okay, what's f prime going to be? 3 times g is just y. G prime is the derivative of y, which is dy dx, and f is 3x. Okay, so
Math it out.
3x squared plus 3y squared dy dx. I'm not going to change that, and I'm going to drop my parentheses, so this is just 3y plus 3x dy dx. Now, what's my strategy?
Subtract the dy dx.
I have 4 pieces. 1, 2, 3, 4.
Put them on the same side.
Which one? Do you want dy dx is on the left or the right?
Right.
You want this one over here?
It doesn't.
And this guy over here? Doesn't matter, right? So this will be 3x squared. He's just chilling minus 3y. Okay, equals, this guy right here stays 3x dy dx minus 3y squared dy dx.
3x
Okay.
minus 3y.
Then some of you guys do this without without, whatever. But if you still want to do that, there's that. You pull dy dx out, O squared. And we've got this. Oh, that's in y. And then we divide this guy over, right? So over 3x minus 3y squared. I can, which I will. I'm going to. All 4 of those pieces will divide nicely by 3, right? So I'm going to get rid of the 3 just because it makes it easier. X squared minus y over x minus y squared. That is what my dy dx is. That is part A.
Would you technically be factoring out a 3 minus 2?
What?
Just factor out a 3, not minus.
Yeah.
Oh, yeah.
My dad did this wrong. Wait.
Yeah.
Oh, wait.
Okay, that's what my derivative is. That's part A. Now, okay, buckle up. We're plugging in 3 halves, comma 3 halves. And in this case, we're plugging in the x and the y, right? Okay, but hold on. Just wait. Maybe. I'm plugging in 3 halves. So 3 halves squared minus 3 halves over 3 halves minus 3 halves squared. Okay, this is what we've got going on here. That's what we get when we plug them in.
Doesn't it just
Okay.
cancel?
I don't know. Maybe it doesn't.
No.
We'll see. What's 3 halves squared? What is this?
Stupid.
6.
9/4.
9/4. Okay. Now I want to combine like terms. 3 halves in terms of fourths. This would be 6/4. True. Okay. So what is 9/4 minus 6/4? This is 3/4. Yeah.
Yeah.
Okay. On the top, on the bottom, we've got 9/4 here. I'm gonna go over here. We've got 9/4 over here. This is 6/4 minus 9/4, which is negative 3/4, right? Now, if you don't understand that cancels out to be a -1, you can keep flipping to the top. So times the negative 4/3, and those are going to cancel, but that ends up being -1, which is what we guessed to begin with, right? A -1 is going to be my slope. Okay? Good?
That wasn't that bad.
That wasn't that bad. Yeah.
History just sucked.
Yeah, but yesterday you guys were doing a really good job with your derivatives, so I was really impressed.
To figure out, but now
Yeah.
Thank
Yeah.
you.
Derivative.
Yeah.
Thank you.
Yeah. This is implicit. What?
The last one of the table, or what?
Oh, wait.
No.
B. Find the equation of the tangent line.
Derivative.
No.
Equation is y equals mx plus b, right?
Oh, yeah.
But what did we find?
Make it slow.
We just found the m, right? So I'm going to put the m right here, but how do I find the b?
Plug it up.
I'm going to plug my point in, which is 3 halves, right? So I'm going to plug 3 halves in here. 3 halves equals -1 times 3 halves plus b, right? So this is -3 halves. And if I add the 3 halves over, what's 3 halves plus 3 halves? 6 halves, which is? 6 halves is 3. So b is 3. So final answer, y equals?
Negative 1x plus b.
Y equals -1x plus 3. There you go. Is that -1x plus 3? Does it look like it's going to intersect up here and have a y-intercept at 3?
Yeah.
Yep, I believe it. I believe it.
We could have took a guess and launched.
Right, but on the homework assignment, you will not have the graph, I'm sure, probably. Or I think you have it maybe on like one problem, right? Okay, good?
You are one to talk. You are always.
Okay.
on the computer.
Yeah, but I'm not.
He understands
Oh, I
it,
don't
though.
understand. I don't understand. Show it
I
to
didn't
me.
say that today. Because I understand.
Today?
Yeah, not
Yeah,
yet.
there you go. Okay,
I'll just stick it.
how do we feel about that? Are we okay?
Yeah.
Implicit? I kind of like implicit. I think it's kind of fun.
One failure.
It's kind of like a little puzzle, okay? So if you did not get up through 10 yesterday done,
Trophic.
work on those, but then you've got these 3. Okay? Good? There you go. You got 7 problems.
Recorded and everything for you.
It's recorded.
Okay?
What are we doing?
Good?
Great today.
All
Did we
right.
learn
Nothing.
anything new
What?
today?
Yeah, did we?
Yeah, we
What?
just were plugging stuff in.
What?
Yesterday we were just taking implicit.
But did we
I'm not talking about you.
learn?
I'm not talking about you.
What did we learn that was new today?
Today we were, I don't know. That was brand new? Nothing.
We were reinforced.
We were reinforcing with implicit. Yes. Okay? There you go. Those 7 problems. Got it? Beautiful.